Let's use the TVM solver on the TI-83 or 84 to find the present value of a series of future payments. In 2004, a Massachusetts cleaning woman, Geraldine Williams, won $294 million in a Mega Millions lottery. She could choose either a lump sum check for $168 million or 26 annual payments of $11,307,692.31, because 26 times 11,307,692.31 is $294 million. Assume annual interest is 6%. Which would we choose? Here are our choices. Choice is a lump sum check for $168 million or 26 annual payments of $11,307,692.31. Here's how we'll solve it. How much money would we have to set aside today at 6% annual interest compounded annually in order to have 26 annual payments of $11,307,692.31? This is what we call the present value of those 26 annual payments. So here's the problem now. Find the present value of a series of 26 annual payments of $11,307,692.31, each made at the end of each year. We will assume that annual interest is 6% compounded annually. We're going to solve this using TVM solver. Here's a reminder of how you access it. For a TI-83 Plus or TI-84, it's apps and finance. Apps or finance, then choose finance and TVM solver. And for regular TI-83, it's just finance and TVM solver. We will enter the values we know, put our cursor at the value we do not know, then press solve, which is alpha enter. So again, here's what you get. Let's turn this on. Let's press apps. We want finance and then TVM solver. So this is what we get. This is what our screen looks like. N is the number of compounding periods. I is the annual interest rate. PV is the present value, or initial amount in case of a loan. PMT is the amount of a regular payment. FV is future value. P/Y is payment periods per year. C/Y is compounding periods per year. And we choose end or begin, depending on whether payments are made at the end or the beginning of the payment period. We're going to let end be the default value. So here's what we get. In this case, N is 26. That's the number of compounding periods because interest is compounded annually. So we have 26 compounding periods. The interest rate is 6%. Don't enter 0.06. On the TI, when you enter the interest rate, it's just a percent, so 6%. Okay, the present value is what we don't know, so we could put anything there. I'll put 0, but really we could put anything. The payment, that's the amount of the regular payment, so that would be 11, so 11,307,692.31. And then enter. The future value is 0. We're not saving up for anything, so let's just make that 0. Payments per year, compounding periods per year. The number of compounding periods per year is 1. So the number of payments per year is the same. Those are both 1. We move the cursor to what we don't know, which is present value, and then press solve. That's alpha enter. Notice what we get. The answer is $147,035,802.30. Notice, too, that it has a minus sign in front of it. That's because it's money that's coming out of our pocket. If we wanted to withdraw $11,307,692.31 every year for the next 26 years, we would first have to deposit $147,035,802.30. So she should take the lump sum check. Assuming 6% annual interest, it's more valuable. Why? If she invests $168 million at 6% annual interest compounded annually and makes 26 annual withdrawals of $11,307,692.31, she will not exhaust the fund. She will have money left over. Now, if she deposited $147,035,802.30 right now and withdrew the $11,307,692.31 every year for 26 years, she would completely exhaust the fund. So she should take the $168 million and run.